Hi, everybody. Welcome to this session. Thank you so much for attending, especially on the Sunday, the last session at the end of a conference. Hopefully you've all been enjoying the time at SIMIODE. I know I've been enjoying the sessions that I've gotten a chance to see. So here our title is Implementing SIMIODE Models in a POGIL Paradigm to Inspire Students. And if anything, at the end of this session, you will hopefully have the idea of what POGIL is in your head when you walk away from the session. So I promise we'll define it in a little bit, but it will be a mystery now for a couple of slides. To start off, So hi, my name is Jacob Blazejewski. I am a PhD candidate in applied mathematics at Michigan Technological University. And this is a joint work presentation with a dear colleague of mine, Dr. Nadun Kulasekera Mudiyanselage. Sorry for the tongue twister. I have been practicing the name though, and I got the thumbs up, so we're good. Nadun is an assistant professor of mathematics at Appalachian State University in Boone, North Carolina, and finished his PhD from Michigan Tech actually last summer. So we have been colleagues for a few years and both really enjoy teaching and pushing each other to get better at teaching and getting each other involved in all sorts of crazy projects around teaching. So he's here just to be able to help answer any questions for kind of this latest venture of ours together into POGIL land. Neither of us claim to be POGIL experts, but we have gone to a few workshops and are working on writing activities and are just excited to share what that can look like in various settings to people, because there's a lot of opportunities to be writing and creating more math content in this setting. The last thing that I just want to address is, so this is a math conference / teaching / presentation. My thing is I always like to make sure to wear a tie and to have a fun tie when relevant, but this is a virtual presentation, so you cannot see it. So up in the right-hand corner is my lovely pie tie. That is the one that I'm wearing for today. So that way we are all in like a good theme and mood for each other. So a little bit about our background. I'm serving as a graduate student, and Nadun served as a graduate teaching instructor. We've taught a variety of courses, including pre-calculus, a lot of Calc 2. We've both had a semester stint in our linear algebra course at Michigan Tech, and this semester I'm getting to do the elementary differential equations course, and Nadun had a lot of experience with it during his time at Michigan Tech as well. At North Carolina now, I believe Nadun has been primarily involved in Calc 2, but getting to do all sorts of other different teaching things. And a key tenet to this presentation is to share with you a little bit of what we share as part of our teaching philosophy, which is this idea of student engagement is being key to their success. And there's really three ways of engaging students. So one is making sure that students can engage with each other as they talk. One is making sure that students get opportunities to engage with their instructors. And then lastly, and very crucially, is that students need meaningful ways to be able to engage with the course content, so that way they learn some knowledge to be able to go forth. This presentation is kind of our latest iteration of trying to meet all of these three things in a new way. So our goals in this session are basically yanked right from the abstract for this talk. So the first is to talk about how we work to adjust an existing SIMIODE activity to fit into the POGIL paradigm. Before we get to that point though, we'll need to talk about what POGIL is to make sure that we're all on the same point. Some of you might have heard of it before, some of you possibly not, but it's just something to be aware of as a different sort of teaching philosophy and way of structuring lessons that can be highly engaging with students. Then after we've talked about POGIL and how it got used in a differential equations course this semester, we'll talk about how I tried to build on the momentum of the SIMIODE / POGIL activity to encourage students to explore differential equations in their own right and find some interesting relevant examples and classify them with terminology that we used in class. And then lastly, some plans for later on in this semester. In a couple of weeks, there's another opportunity to do some SIMIODE and POGIL stuff again that I am actively working on drafting, and so just kind of sharing with where that stuff is at. So to start off, what is POGIL? So the lovely acronym for POGIL stands for Process-Oriented Guided Inquiry Learning. And at its core, it's really a way of combining two highly interactive teaching philosophies. One of those so there are 4 tenets that I have listed with the numbers here, but I think the graphic really does the best way of explaining what the wide bird's eye view of what POGIL is. So that is, it's broken into 2 ways. One is a guided inquiry or constructivism learning that goes through a learning cycle that we'll talk about what a learning cycle is on the next slide. But the main idea here is students are not being told all the facts as like what happens in a traditional lecture style. Instead, students are given an activity that helps guide them in a very careful way to construct the knowledge of the content that you're covering. Hence a guided inquiry as one of the approaches. Then for the other part of this, each of these activities, students are put into small groups and given roles and ownership in the learning that takes place in this group. So part of that is to have group work and be able to develop what POGIL calls process skills. We'll see the full list of what these process skills are later on, but basically it's a way of trying to formally include a lot of soft skills as part of a lesson that are often key buzzwords that employers are looking for and we as educators always like to advocate for, but it's a way of formalizing including them in the instruction. So these are things like teamwork and critical thinking and information processing. And we'll see some examples of what that looks like in a little bit. But you take these two paradigms and you put them together, and that's what you get for things like a POGIL activity. So to come back to this guided inquiry or constructivism piece, that's for what comes down to the learning cycle. So for the POGIL project, they define the learning cycle into 3 phases. So exploration, concept invention, and application. For these activities that students are given, they have a standard format in the POGIL with the POGIL project. And that structure is there are various models, but this isn't a model in like the SIMIODE sense that you are given a set of data and we want to try to model how well this data works. It's actually about here is some figure or some text or some piece of course content or an analogy to an idea of course content that's presented as the model. And then for students to engage with the model, they progress through the learning cycle and they begin with exploration, which you ask questions, targeted questions to get students to notice key features about the model that you are working with or things that are going to be important for later on. And from there, they get to invent a concept. Another key tenet of POGIL is to go along with you're helping students construct knowledge rather than telling them, is you really keep jargon to a minimum for as long as possible, meaning that you try to get students comfortable or introduce an idea to students before you formally define it, which is a different way to think about it from a teaching perspective, because for lectures, you're used to saying, here's the definition, and then let's go through. This flips it on its head of saying, here's this idea, and then let's take a look at what the definition, what it is that we have just defined, which from lecture style feels not intuitive, but from a learning style feels much more intuitive. It's easier to get a grasp and a hold on what an idea is before you sometimes put really big jargony names to it. So then once we have invented a concept, help students, guided them to invent a concept, well, now we're ready to take that concept and apply it to something, maybe apply it in a new context, maybe extend upon the concept to an even broader sense. So for this learning cycle, if that description felt pretty vague and abstract, it kind of was by design at this point. I know for me, the learning cycle is something that it can be it's nicest to see in the context of an example. So let's see an example. And the example I have is an activity that Nadun and I have worked on drafting for Calculus 2, where our goal here is to just kind of get a taste of what does a learning cycle activity and POGIL activity look like in context. So our activity is about approximating the area under an integral curve. So we would assume that students have already been studying some integration strategies, and now how could you process developing why do we need to approximate integrals? How do you approximate integrals? So our first model targets the left endpoint and right endpoint rules, where we have a quick little setup of some function that we're saying this function is modeling the velocity of a swinging pendulum. And then these two graphs, both being of the same function, one with rectangles and one without rectangles. So that's our model. And to guide students through this model in a POGIL context, what we want to do next is to help them explore all of this information. So we ask some questions like, well, what's the time range that we are modeling on? Our goal with this is we want to emphasize area. So we want to give students a chance to shade the area under the curve in figure 1, because that's ultimately what we want to approximate. We want to activate some prior knowledge of remembering that, okay, students are interested in finding the area under a curve, and this relates to integrals. So that's what with question 3 is. We're taking the integral. We want them to connect it to the area under the curve. And then we also want them to take a moment to say, hey, for this integral, let's motivate why we would want to be considering approximating an integrals. And that's, we all know, you don't always have the chance to find an antiderivative. So sometimes you need to do an approximation. And so then we introduce the idea of, well, what can you do to approximate? And that's, you can use rectangles to get a rough approximation. And that kind of finishes the explore piece for identifying all of the stuff up here that we then kind of move into the construction of knowledge, which is to walk them through, okay, well, how could you actually approximate this integral? Well, we've given them these nice rectangles. So that means let's find the area of each rectangle and then add them all up, which is precisely what this next part deals with. And in the midst of this, there are some stopping points for instructors to check in with the group and make sure that they're on an okay track. And after they have constructed and approximated the area of the integral using the left endpoint, the left endpoint. Well, now our apply piece is, let's go ahead and get a chance to repeat this exercise and do it with the right endpoint. And they get to think through and work through all of that with some helping prompts that we have provided them with. A good POGIL activity as you work through it, as you're working through it, should not feel frustrating at any point. It really should kind of feel like all of these questions really naturally fall from each other. So getting good POGIL activities is really an art form and a craft that we are definitely novices at, but working to improve ourselves with. But from a student's perspective, it should be something that all flows naturally. And it can be tempting to say, well, maybe you're cheating with some of the stuff that you're providing them with, but part of the design of the activity is to make sure that you're not putting too high of a level on any question that a student, too high of a bar that a student has to jump over. So this is just the first model that's working through this concrete example. But then you get to scaffold models together and go through another learning cycle where our second model for this activity is then now to say, okay, we've constructed some formulas, or we did some approximations in a concrete example. So now let's extend this idea to be a little bit more general to inevitably arrive at formulas for the left endpoint rule and the right endpoint rule, but making sure to take care to help students develop this idea of an arbitrary number of intervals occurring, which can be really tricky for students to get the abstraction piece correctly. All right. Also, thank you, Nadun, for monitoring the chat. If I've missed something in the chat, I promise, or so, are we all good for everything? Yes, okay. All right, so that's kind of an example to hopefully be a little bit more concrete about what it looks like for the learning cycle. So that's all the guided inquiry silo. Now on the other side, well, what does it mean for this process skills piece? As we said, these activities are done in small groups where group work can be dangerous when you give it to students. Dangerous because it can quickly devolve into social hour, or students can not necessarily all contribute, or you have any sort of issues that can happen. So for the idea of POGIL is each student is given a particular role that helps actively contribute towards the learning of the group. So each student has some individual ownership in the success of whether the group is continuing or not. The standard roles that they include would be a manager, presenter, recorder, and reflector. The manager is a person that's in charge of making sure to keep time and keep everybody on task and focused as we are moving through, as well as making sure that everybody has a chance to participate in the course discussions. They don't need to, and understanding what the content that you're moving through. It's not necessary that they explain everything. It's necessary that they make sure everybody's contributing and everybody's following along with what's going on. The manager is also somebody that was recommended to set a reader. So for that activity, when you give worksheets like that, it can be tempted to say, all right, I'm going to do question 1, Nadun will do question 2, Arati will do question 3, and then at the end, we'll all compare our answers. But that's not how you should work through one of these projects. You should be working through them all together and making sure everybody's understanding what's happening every step of the way. So a reader is good to keep everybody on the same page, and manager kind of drives discussion as we're going forward. The presenter is basically the liaison between any of the small groups and the larger group, between the group and the class as a whole, for if the instructor wants to see and check in for what did everybody get for question 2, well, then the presenter tells what they got for their answer in that group. The presenter is also placed there to help ask questions on behalf of the group. So if the group decides amongst themselves they have a question, well, then it's the presenter that asks that communicates that to the instructor, not just anybody in the group. And then the 2 final roles, the recorder, responsible for recording all of the discussion that takes place. The activity itself is not something that needs to be collected or graded. You certainly could, but the way I view them is it's the notes from the day that students need to understand. So the recorder keeps track of who's all in their group, keeps a nice document of the discussion, and makes sure to share that with group mates afterwards. And then the reflector is a role that's probably most critical if you do a lot of POGIL activities. Their main job is to make sure, okay, everybody, to make sure that we are functioning well as a team and give suggestions if there are possible issues in the team's functioning. So those are the 4 groups that you would be welcome to modify in any way. This is just kind of the recommended structure that POGIL has. And so also with this process skills are the process skills themselves, which the POGIL project defines 7 total skills, that these all have pretty standard definitions that go with them. So assessment, critical thinking, information processing, management, oral and written communication, problem solving, and teamwork. For these process skills, they also, since you're trying to target these, in addition to learning objectives for any of the learning goals that you're doing, it's also good to have a process skills objective with each activity. So for example, with our approximating integrals, our goal would be to target information processing with something like students will be able to generate a formula for approximating the area of a given curve using left or right rectangle rules, where this might not be the traditional information processing of you're producing an image. We're flipping the script slightly in that we are talking about images or data, and we want students to be able to translate that accurately into what it means to be approximating the area in terms of all of these formulas for different things. So we have those 2 key pieces with our process skills and the guided inquiry learning. That together encapsulates all of POGIL, and we will now be ready to actually tackle part one of our goal of this talk, but first we had to make sure we were all on the same page for what POGIL is. Before I just dive into that, so we've been going for about 20 minutes. Talks can get long, especially at the end of the conference. So just a quick pause here. We won't do a big formal break or anything, but any questions for the POGIL part itself? I promise the next part is talking about how it goes to SIMIODE itself. But any questions? I'll take a sip of coffee to give people a chance to type or anything.
Any questions from?
Not so much a question, but I thought maybe it would be helpful to let you know a little bit more about your audience.
Yes.
Because Cecil and I, the non-moderator participants in here, we're both high school teachers. So we are looking at or teaching modeling courses at the high school level as opposed to the college level. So just so you have a sense of kind of like the level on which we're operating.
Cool. Awesome. Thank you so much for that. Just to say that I know in the POGIL community, there are also lots of people doing activities like this in high school too.
Oh yeah, for sure. My high school, we use a CPM curriculum, which is basically a POGIL curriculum. I mean, they take all the POGIL principles and implement it pretty faithfully.
So there you go. Excellent. Well, I hope that there was still hopefully some little new nugget in that, and it wasn't all repeated.
The way you talked about the roles was definitely different than the way my current curriculum does. I actually kind of like the framing that you gave to the roles a little bit better than the way I've been doing them. So I will probably be using that in the near future. Thank you.
Feel free. You're welcome. So I also saw that there was a question about graded materials that thanks for Nadun answering. You can grade the materials if you want, but not required by the nature of the activities. From some of the workshops that we attended, I don't even think, I believe for some of the high school people, they weren't necessarily grading everything. So that's not a requirement. You could if you wanted. You might drive yourself a little bit crazy if you try to do that. But I would say that's kind of to each individual person. There is a, So
Jacob, I have a quick question.
Yeah.
So I liked it very well. I mean, giving the skills very well described. So my question is that you have divided 4 categories, manager and those things. So you have this process learning, the learning skills. So how you divide their workload as a manager, as a recorder, as a assessment. So how which part they take, or everybody is doing the process and then?
So the whole group should be gaining like the process skill. So like a process skill would mean one of these things that they get a chance to work on. But then for roles, each group member gets just one role. For assigning roles, you can do lots of different things. You can randomly assign them. You can let students choose. For the activity that I did that we'll share shortly here, so there were only three roles that I used: a manager, presenter, and recorder. I made sure to explain what all the roles were. I gave students a minute to choose, and if they hadn't chose, so each student got an individual copy of the activity that I put a number on, and I passed them out in groups of 3. So if at the end of that minute students did not have a role picked, I said, look at your number. If you're a 1, you're this. If you're a 2, you're this. If you're a 3, you're this. And so now keep moving through.
So it is like, let's say if they are doing this project, one person will be the manager. When they're going to the next project, that person can be the reflector or the recorder, so that everybody will get the experience of all 4. That's good.
Absolutely. Absolutely. It probably depends how frequent, to answer Cecil's question, it probably depends how frequently you are using the activities. If I probably will only have a chance to do this about twice this semester, so I'm not really monitoring which students do what. If I were to do it more regularly, I would probably want to make sure initially students are kind of cycling through the roles so that they all get practice at them and an appreciation for what's involved. But then after that, I would probably let students choose whichever group role they're most comfortable with. So that way groups feel like, okay, I know I'm good at this. So that way we can focus on our learning, if that makes sense.
Yes.
Great questions. Have I missed anything in the chat, or are we all caught up on anything? on everything, just to make sure. Okay. Other questions for that stuff? And I promise there's time for questions at the end too, that more than happy to talk about anything. I do not do POGIL every day. I know some people could do POGIL every day. I've tried to target POGIL to specific application days as a way of kind of changing up the pace of a college course rather than just constantly lecturing a whole bunch of times, to say like, let's do something a little different for those days. You could do it absolutely more. I don't know that students would necessarily appreciate it every day. So I think it depends on knowing the level of your students and what they're comfortable with.
For example, as you said, you have to finish the course also. It's not like, and if the course, let's say it is a standard course, you are not the alone, and you have to complete certain amount of course list for the final standard exam, then you have to manage your time also.
Exactly,
Yeah.
exactly. So for me, the way I'm trying to use them this semester is where there's already kind of a squishy point in a differential equations course, which is talking about applications of the differential equations and stuff. So I got lectured through all the primary stuff, but now we get to try to see, okay, let's have a little bit of fun of doing something different. With that, for the activity I chose to go with is one that I have the most experience with, which is this idea of mixing problems for a first order differential equation that happen both in Calc 2 and I think are possibly applicable in the high school curriculum, but I don't know exactly where, and I might be overstating that. So I'm sorry to our audience members if I've said wrong information there. But with that, there is an existing activity by the fearless director, Brian Winkle of the SIMIODE project. His activity starts off with a fairly standard description that this is what you would find really in any textbook about a mixing problem. And it is a nice activity for the amount of exploring that students get to do. The first question is basically, here's your description, so now go ahead and set up a differential equation. Depending upon the level of your students and where they're at, I would be timid about just giving students to this sort of question cold, because setting up this differential equation involves a lot of minute details that are not in and of themselves overly difficult, but if students have not seen how to piece them together before, some might rise to the challenge and some might not. So with a POGIL activity, the idea is to help get them to this activity or to this question by giving them some ladder rungs to climb to reach towards the end there. So what does it look like to try to POGIL this activity a little bit? Well, for me, I took the word description and I changed it into a figure. And for me, this is my first model that now if we're going to progress through the learning cycle, the goal is to try to get students to explore this as well as invent a little bit of a concept. So for exploring, for me, what I have them do is make sure to notice, okay, well, how much salt is initially in the tank? What is the initial concentration of salt? And these questions I've truncated from what my handout actually is. I want to make sure to emphasize that at the end of all these, there's also a prompt for students to think about units, because unit analysis is something important and really informative to make sure that you've set up the differential equation as something that makes sense. So then also at what rate is salt entering the tank, and making sure to keep track of units. And then we get to question D, that this was where I uncovered a lot of students' uncomfortability kind of with what we were doing, which was if there's 80 pounds of salt in the tank at time T, what's the concentration of salt at that time? So what a lot of students were trying to do was to say, all right, this A of T, let me make a function for it, because I know how much salt is in the tank initially, and I know how much salt is entering the tank. So let me try to write down an expression. They would not necessarily adequately account for this draining pipe that's happening here, that this drains away salt solution and also impacts the amount of salt in the system. So this abstraction piece kind of tricky for them that we took a timeout from the overall group discussion, and we took a moment to say, all right, what does this A of T mean in this concentration and how it links back up to the other piece? So with POGIL, it doesn't need to be just constant group work. You're allowed to do kind of mini lectures to help move things along or to correct different errors as they occur. And then after that, a little bit more of making sure that they identify what's the rate of salt exiting the tank. And then now, after having done all of this exploration, letting them construct the differential equation, which students get the idea of it would be rate in minus rate out. The questions are to just help them form those pieces that they can get to put together. And while this takes a little bit of time, or it feels like a little bit of time in making the activity more complex, it's really worth its weight in gold, because once you have done something like this really well once, if a student has taken the time to make sure they understand it, well, now they have the scaffold to be able to apply to other problems and to do to other things. So from here, I let my students apply stuff in a more standard SIMIODE context way of they look at slope and direction fields of this differential equation that they just formed after they've checked in with me that they have the right differential equation. And then in my next model, I give them another mixing problem scenario setup that I don't bother going through all of this explore in the same way. Instead, they have a chance to write out the differential equation using all of the good tools that they would have built up from this model. And then they can go ahead and go forward and actually solve the differential equation using techniques that we have already talked about. So kind of a way for what the activity looks like. And then for the group work, it would have been groups of 3. My class size is large. I have over 80 students in the class. So it was a busy day of walking around, but in a good way. So just some reflections, kind of two-pronged. So from my part, it was really nice to be in a classroom again, especially after all of these tumultuous semesters, as I'm sure all of us being in the education game and COVID, we know that it's just not been normal recently. So it was nice to get some semblance of normal, of listening to students having good discussions in and amongst themselves. And they were active about it too. I know for myself, it is definitely a craft at writing these activities from scratch. And so in doing that, definitely testing with students in the classroom is good to get feedback about what stuff you can make better. So for me, we just did this activity 2 weeks ago. I definitely want to improve it by adding a couple more exploration questions, making sure that they get comfortable with this idea that we're supposed to have this unknown A that goes eventually into the differential equation, and even trying to prod them with some notation of our differential equation. Well, we're going to want to find what is dA over dt, an expression for what that is equal to. Things that are sometimes second nature as you're talking through them in a lecture style, but you don't necessarily think, oh yeah, we need to have a moment to remember to do that stuff. Also, as I said, it's okay to do some recap moments to correct any group misunderstandings to try to keep them all on track. And then lastly, baking can be an incredibly powerful motivator. So for me, something I usually like to do for students is bring in a baked good around an exam time. They're stressed, so it's a chance to have a baked good, relieve some stress. I also like to stress bake, so it's a good matchup. In this case, Nadun recommended harnessing that idea and encouraging students with some cookies. So I had a plate of cookies that I would give to the group that made it to a certain point in the activity first for the day. And then I had more individually packaged for everybody at the end, which they all seem to appreciate, which is good. Also, a word of caution with some of this stuff, for at least at the undergrad level, because I had some experience trying this stuff last semester as well too. The worksheet tends to be fairly well received by students. I did a survey after this one, but not that many students responded, so I'm sorry I don't have better statistics to report. But I thought this comment was fairly insightful in that they enjoyed the worksheet, but the group work itself was something they didn't find as beneficial. They prefer a lecture style of class. And that's fine. It's okay for students to feel that way and want that benefit. If you are implementing these activities, it's really worthwhile to take time and explain why you're also choosing to do the group work for highlighting the process skills and how that is actually something that's also a benefit to them. It could be frustrating because it feels like you're getting through stuff a little bit slower, but there's also other stuff that you are gaining. So for me, it's just about thinking, reflecting, and making sure to pay careful attention about better ways to get student buy-in, especially into the group work activity stuff. So with that, that takes care of goal 1 from the presentation. So now on to goal 2 for the presentation. This was mixing problems, which is just one of many applications of ODEs. For us, Michigan Tech is an engineering institution. Probably only chemical engineers found the mixing problem the most relevant differential equation. So at the end, I want to take a moment to give students a chance to find where differential equations are relevant to them. And for me as an instructor, that's a very individual answer that I don't know where it's relevant to all of them. So at the end of this, I gave them a chance to try to say, okay, go ahead and try to find an application that's interesting to you, that's involved in your study or just interesting to you. I want you to go on Google, go look in the book, find a differential equation, and give me a short description, write down the differential equation and give me a short description of it. And then for where we start our differential equation course, so we first learn about classifying differential equations based on order, linearity, homogeneity. So then I tried to link back in some course content by saying, okay, now try to classify the differential equation. And this to me was an activity I had thought of ever since I knew I was going to be doing differential equations this semester, that I was really intrigued to see what I would get. So I want to share what some of the things that happen with students. First of all, a disclaimer that not all responses, as I'm sure we can imagine, are stellar and exactly what you want. Some definitely are lacking a little bit. So the format of this is the first part, they should tell me about their differential equation. And then the second part is really just, okay, what made it interesting to you? So not all of them knocked it out of the park, but a couple really did and showed me new ways that I hadn't even thought of differential equations. So for a really nice example of student work, this is probably my favorite one. So this student found a differential equation that this is monitoring the rate of change of a fire radius of a fire burning in some location based on various parameters that they describe in their description. But the reason why the student found this so relevant is that they're a volunteer firefighter and a STEM advocate. So it was really cool for a student to have a chance to find something relevant for them, me to learn about a new differential equation, as well as learn a little bit about my students too. Just a couple of other examples that I want to share as well. So this student found a standard population model that appeared on multiple, but they had fun, just like instructors sometimes try to jazz stuff up, that they didn't bother with a standard population. They modeled it with zombies, which was definitely exciting to see. And there were other standard differential equations that students kind of put their own twists on. That it was also nice with some of these students talking about, so the differential equation modeling a population, and multiple of them made a comment that it's so cool that you can show exactly how a population grows, which gave me the opportunity to prod them with a question of, well, a differential equation is just a model. So you need to remember to pay careful attention to what all the assumptions are that are built into this model, and having good SIMIODE type discussions around that. And then a last example that I want to show is to highlight a student that found a very cool system of equations relative to some health science interests. And for me, a question like this is cool, one for the application, but then two, to say to the student, great example, by the way, coming up towards the end of the semester, we're going to look at systems of differential equations. So you have something to look forward to, and you might be able to solve this later. And there were other students that came up with mass spring system examples as well too, that I was excited to say basically the same thing with. So this was the goal of trying to help them explore, find stuff relevant to them, hopefully be inspired in some sense going forward forward in this course to go, oh, okay, yes, differential equations. There's stuff that can be cool or interesting. They don't need to be a math nut, but they can find a little nugget that goes, huh, that's kind of cool. And so now on to the third point of our presentation, which is to say, so moving forward, as I said, we're going to talk about mass spring systems. This is another chance to do application problems for a higher order differential equation. So I intend on trying to do kind of a POGIL SIMIODE combination model together that I'm still actively writing, where for a learning objective, the goal is we have our second order differential equation that I want students to be able to solve. But it also pairs nicely with an objective, process skills objective that I right now am thinking kind of along the lines of metacognition, but that could change. For with this differential equation, there are a lot of different cases that can fall out depending upon what's involved in your system and your assumptions. So I want students to kind of be able to summarize all of them. For the POGIL activity, I think I would focus it on damped motion and exploring your critically damped, overdamped, and underdamped cases with kind of like our approximate integral, some concrete, here are the numbers, then more generally, okay, what does this mean in the sense of the formula? And then lastly, also saying, okay, what happens if you include a driving force as well on these, and how does that impact everything? So that's just a little taste of something else for where to go for trying to embrace a POGIL mindset for going forward. In case you are interested, some of our audience members might find this intriguing, although I don't know that it aligns formally with high school curriculum standards, so that could be something to be careful of. But there are some groups that have worked on creating whole POGIL textbooks, some for pre-calculus, which is the one on the left, as well as Calculus 1. Nadun and I are actually trying to help continue towards this body by working on some Calculus 2 activities and just other various things as we go forward. So if you are interested in possibly exploring and writing other activities along these lines, we would love to hear from you, which is why I included our emails. For an activity to get the official POGIL certification label, so the activity needs to be peer reviewed among POGIL people, and also needs to get classroom tested. So even if you don't want to write, if you're like, I'm willing to try stuff in classes, we would also be interested to hear from you. There is a big lane open for a lot of math stuff to be done. POGIL originated more in the chemistry curriculum, but I think we think it has a lot of potential value to be added to the math curriculum as well. So with that, I think I'm pretty close to time. I'm hopefully not over. My timer says 41 minutes, so I think I'm within my time frame. So I want to close with just a chance to address any questions. And then lastly, just sincerely from the bottom of our hearts to say, thanks for sticking it out towards the end. We really appreciate you attending our session. So thank you.
Thank you. This is very great. And I think you gave many, many things for our audience. And anybody has questions? I have one question. Not actually question. I'm like, you are saying that you are interested your students to write down their differential equations. So are you encouraging them to join the SCUDEM? It's a part of SIMIODE competition.
That I have not had a chance to talk about or
For
share with them at all.
Student, please do that.
I will make sure to try to mention that and include it. So this is my first time teaching differential equations in a regular semester. So I'm definitely still getting feet on the ground for everything, but I will absolutely keep that in mind as a cool thing to encourage, because I'm sure there are a couple that would be very interested in the challenge.
I have a question.
Thank you for that note.
Right.
Mm-hmm.
So one of the things, so I'm actually, I don't teach differential equations at my school right now. I'm actually looking at implementing a modeling course that does not rely on analytic solutions. So it's not a traditional like sequencing at all, but the idea is to motivate high school students who might be interested in sciences or engineering, that sort of thing.
Super cool.
One of the things that I'm really interested in doing in this course is really approaching the metacognition and the modeling cycle and the process of modeling very explicitly in the class. So do you have any thoughts on using this approach to actually teach those that kind of the overall structure of the modeling process?
Great question. Nadun, if you have thoughts, definitely buzz in. For myself, for thinking about the modeling process overall, so I have not taught a specific modeling course. Nadun has one coming up though, so he might have good thoughts with this. For me, it would be about making sure to model what good modeling looks like, probably initially trying to help guide them through a couple of standard modeling examples. And then for the metacognition, trying to have them reflect on and say, okay, what was some of our process? What were some constant steps that we always did in constructing our models, and for why would we want to do that? Why would that be important? Why would we maybe want a test case? Why do we think about units? Why do we need data? What do we need to be careful about when gathering data? I'm not sure if that's online with what you're interested for thinking about or not, so please ask more questions. And Nadun, if you've got any comments, by all means.
Yeah, one thing that I would say is that what I'm trying to think about doing with my upcoming modeling class is to think, to model stuff that they are interested in. So we could ask, okay, so what are you interested in modeling? So maybe they are interested in what happens in social media or something like that, or maybe they want to model a game. Maybe a board game or something like that. So maybe picking up examples that are relevant to them, really relevant to our generation, and then include them into this kind of a POGIL or a kind of a format would be nice. Yeah, that's something that I'm thinking about doing with my introduction to simulation class next semester.
So Nathan, as I was talking to you yesterday, I was telling you that we have a rich content in SIMIODE. So you can just explore, so beautiful, starting from the very basic beginning, and students will get the beautiful approach. What is the meaning of modeling? Why you want to do it? It's so beautiful, rich. And from the starts with the very elementary approach. And the starting point is M&M death modeling. Then you can approach M&M death and immigration. And then you can see so vast, it's so beautiful. You cannot stop appreciating. So
my question was more about the actual process of modeling though. I want, so right, the process of modeling is you look at a real situation, you abstract it into a model that's not mathematical, and then you take that model and you make it mathematical and you solve it mathematically. And then you go back and interpret that solution in the real world context. And like, yeah. I want to be able to describe that whole process and explicitly teach that to students, but I think it would be better to do it within a constructivist approach.
Yes,
to it.
Yeah, that's the whole idea. You start from like just the word problem, like not even word problem. Like M&M starts with, you take some M&Ms, the chocolates, you play with this, and then you observe what is going on with that, and keep that record that, okay, you play with this, and then keep some record. Of course, you have to assume certain things, and you will see a pattern, and your goal is to write down that observation, just an algebraic equation as just a mathematical formula, and then gradually you can develop something called a differential equation. And it's so beautiful. It's just start with that. M&M from SIMIODE. And then you can go modeling like cancer death modeling, or like, let's say, I do mechanical heart valve modeling, and I appreciated this M&M modeling. It's, you won't believe.
And to possibly try to merge that with a POGIL idea. So part of that would be, you want to give students something that feels concrete initially, like that's like, okay, we can potentially do something about this. So some analogy with the M&Ms would work. In my head, population models are something very nice for concrete, like, discussion about what's going on, because for constructing your model of a population, well, you can think about it non-mathematically, but also when you get to it mathematically, you need to think about, okay, well, what sorts of equations maybe make sense to model a population with. So for high school level, they would definitely start with lines. And does a line make sense to do this? No. Well, what about a quadratic? Would a quadratic work better? Well, partially maybe. What about an exponential function? Well, initially, yeah, an exponential function will work, but then inevitably it's going to fail at some point. So I think reiterating something, to tackle like just the general modeling right off the bat is probably going to be hard to do with just one POGIL activity. I feel like you want to have stuff set up to model in various small contexts that like, okay, we can do this modeling. And then after that, try to think about, so what are the things that seem to be in common, and was there anything that was unique? Because modeling in and of itself is a very big beast. There's kind of a standard process, but really, well, what are you modeling? That's the first question. And then, well, how do we proceed from there? Well, let's think about it. Depends on your context for what you're doing. And so possibly doing standard examples, then giving them a chance to find something that they want to model, and then trying to consider, well, is anything that we've done before relevant to this? If so, cool, how does that work? And if not, well, why doesn't it work? Is there anything else that we could try to see?
Thank you.
So thank you. I think we are a little bit over time, but we had a great discussion, and I appreciate your presentation. It was beautifully presented, and a lot of good practical things we got to learn. And thank you very much for all of this. And thank you, Nathan, and all others. I cannot see all of the names, but everybody who could join us. And now let's go celebrate our game.
Thank you. Good luck on the modeling course, Nathan, too, by the way.
Thank you. I'm really excited. It's actually, I'm really excited. Of course, there will be speed bumps, but it's going to be tons of fun.
No.
Get through it.
Yeah.
Thank you.
Thank you all.
All right. Have a good day, everyone.
Yeah.
Yep.
Yeah.